Alright guys, welcome back to chemistry. We're still talking about mole conversions. This week we're doing two-step mole conversions. So far we've converted between mass and volume. Two steps, we go from mass to moles and then moles to volume. So it's a two-step process. And then last time we went between mass and molecules. So we either started with grams, converted to moles, and took it to molecules, or they gave us molecules, we converted to moles, and then converted it to grams. Two-step problems. So guys, just remember, we only care about two places here, our starting point and ending point in any equation they give us, any question they give us where they want mole conversions. And then we have our conversion factors. This is what goes in a dimensional analysis box. This is where all your numbers come from. If you're comparing between moles and grams or mass, you're going to have to break apart that molecule we gave you and add up the weights from the periodic table. If you're converting with moles and 6.02, remember this is a how many number. It's like dozen, 12. 1 mole equals 6.02 times 10 to the 23rd. So if I had 1 mole of eggs, you would have 6.02 times 10 to the 23rd eggs. But in chemistry, we're talking about atoms, molecules, and particles. We also learned that at STP, standard temperature and pressure, 1 mole is equal to 22.4 liters. So now we're able to convert between moles and liters. And that brings us to today. Today we're going to be converting between volume and molecules. Now there's a big thing you need to look at when we convert between volume and molecules here. Do we need grams when we convert between volume and molecules? If we go from here to moles to molecules or molecules to moles to volume, do we ever use mass? No, we don't, right? We totally skip it. So you don't worry about calculating the GFM. You only do that if you're going between moles and grams. But when we're going between volumes and molecules, we don't need GFM. You just use the given numbers. So this brings me to today's stuff. Calculating between volume and molecules. Our first example has us going from molecules to volume. So let's take a look at what we got going here. Now I'm going to write down my starting point, 1.34 times 10 to the 23rd molecules of NH3. Okay. Now I'm going to set up my dimensional analysis. How many sets of boxes do I need? Let's take a quick look. I'm going from molecules to volume. So this is step 1, takes me to moles. Step 2 takes me to volume. So it's a two-step, so I need 2 sets of boxes here. Okay. Now it's time to plug in units. Remember, not numbers, just units. So we're only going to put out units, but this is easy. Whatever's up here goes down here. So I got molecules here, so I'm going to put molecules down there. Now, where do we always go to first? Unless you're in moles, you got to convert to moles first, right? So we're going to go to moles first. Whatever's up here goes down there, so moles go down there. And finally, where did they want us to go to in this question? They wanted us to go to liters. Now I've got to plug in numbers. The numbers come from your conversion factors right here. First of all, moles. What do moles always get? Moles always get 1, so I'm going to put a 1 here and a 1 there. What does volume always get? The liters. What does liters get? Look right here. Liters always get 22.4. And finally, what does molecules always get? Here's the molecules. Molecules always get 6.02 times 10 to the 23rd. So guys, when we're converting between molecules and volume, there's really nothing to figure out. We just got to plug everything in and then solve. So now, we're going to multiply the top together and we're going to get a number. We're going to multiply the bottom together and we're going to get a number, and we're going to save dividing for last. So let's go ahead and do this now. If I took 6.02 times 10 to the 23rd times 1, that gives me 6.02 times 10 to the 23rd. Now I'm going to multiply the top together, so let me get my calculator. So if I go 1.34 times 10 to the 23rd times 1 times 22.4, that's going to give me 3.00 times 10 to the 24th. Now I'm going to divide these two. So let me get my calculator and divide these two. So if I go 3.00 times 10 to the 24th divided by 6.02 times 10 to the 23rd, that gives me 4.99 liters of NH3. So if I start with this many molecules of NH3, I'm going to end up with 4.99 liters of NH3 gas. So now let's look at the next example. This one was going from molecules to volume. So let's look at the next example. This time they're starting us off with volume, and they want me to go to molecules. So we're reversing the process now from what we just did. So I'm going to start off with what they just gave me, 8.5 liters. Now, I'm going from liters to molecules. So I pull out my Y diagram. I'm starting up here at liters, and I got to go to molecules. So step 1, I go to moles first. Step 2, then molecules. So it is a two-step problem. So I'm going to draw my two sets of boxes here. Now, this is what they gave me. So you always start off with what they gave you, and we're only going to put out units first. So let's put out our units. Whatever's up here goes down there. So I'm going to put liters. Where do we always convert to first? You always go to moles first. So I'm going to put moles here. Whatever's up here goes down there. So I'm going to put moles here. And finally, once we're in moles, we can go anywhere. So we're going to go to molecules. Now it's time to plug in numbers. Remember, our numbers always comes from our conversion factors here. So let's take a look. Moles always get what? Moles always get 1, so I'm going to put my 1s in the mole spot. What do molecules always get? Molecules and atoms always get 6.02 times 10 to the 23rd. And what does liters always get? Liters always use 22.4. Again, we don't have to calculate molar mass or GFM because we don't need it. We're just going between liters and molecules. So now, it's time to do the math. We're going to multiply the top together. We're going to get some number. We're going to multiply the bottom together. We're going to get some number, and we're going to divide last. So 22.4 times 1, 22.4. Now let me multiply the top together. Let me pull out my trusty calculator. Okay. So if I go 8.5 times 1 times 6.02 times 10 to the 23rd, that's going to give me 5.117 times 10 to the 24th. So if I take this number and divide it by 22.4, you're going to get 2.28 times 10 to the 23rd molecules. So what that means is, if you have 8.5 liters of CO2, that means you have 2.28 times 10 to the 23rd molecules of CO2. That's a lot of molecules. But again, that's a lot of liters too. This is how it works, guys. As you're noticing, we keep doing the same thing over and over again. We're starting off with our given. We put it down here. We convert to moles, mole to mole. We put our last unit there. We're always doing the same thing. But this is how you convert between molecules and volume, guys. And I hope this helps. Again, if you're still struggling with this, stop, rewind it, and watch again slowly and learn the process, because you're just following steps, but you're doing the same steps over and over again using the Y diagram and the conversions. Okay? Hope this helps. Have a great day.